shots. But on the Photoshop, they can do incredible stuff.
Yeah, we're gonna make you look good, so don't worry too much.
Is that
I
like
would have
bothering you
shaved.
at all?
No.
No?
Should it?
No.
Okay.
That's good if it doesn't.
Yeah. Pretty. It bothers
Is it
you.
recording? Yeah. Okay.
All right.
What was I saying? You did undergrad in math and
I started the E first, and then, like I said, you need what, 134 credit, huge amount. After my junior year, it was obvious that engineering was not for me.
What was it about engineering? Because I had the same experience.
Well, I'm going to tell you what. I mean, I'm an old guy. I was born in '57, and I grew up. I'm from Haiti, and I grew up in Morocco, and I grew up in the French system. So I got my what the French call baccalaureate, which is the high school diploma in Bethesda. In the French, there's a French school, which is on the old Georgetown Road. I don't know if you know it, close to DC.
Mm-hmm.
And at the time, the thing that was interesting me, I think when I was 14 or 15, I read an article about, what do you call this thing? The transistor, which somebody got the Nobel Prize for. It came out in '57 or whatever. And, it was electrical engineering, and I'm like, oh, that's kind of cool. I mean, I was pretty good in math, that's all I was pretty good at. And when it was time to apply to Maryland, you had to give them a major. And for some reason, I didn't know that you could do math. I don't know why I got confused. I said, well, electrical engineering, why not? And then I was bored to death. I mean, it never clicked.
I studied mechanical, and I enjoyed it.
Lucky.
The math intensive parts.
Well, that's okay. Well, that's the thing. I like the math. Okay, so, it's kind of funny because I started as an engineer, and then in the French system, we did a lot of proofs. It's like in high school you do more proofs than integrating and stuff like that. So I was pretty good at proofs. I mean, a lot of the stuff that you go in grad school now, I really was doing in high school, really, in terms of proofs. But I was not very quick at integration or stuff like that. And then at Maryland College Park in my second semester, I took Calculus 3, and it just killed me. I really was overwhelmed. I mean, I was in trouble. I mean, I probably got a B, but it was not, because usually in math I don't, I never had any issues. I just did math and that was it. So I said, forget math. I'm not gonna do math at all. And I did that engineering stuff. I don't know if you're electrical engineering, you had to take. Actually, you had to take some of your courses. You had to take like statics,
Yes.
mechanics. But then you had to take engineering.
Dynamics.
That's it, dynamics. That's why.
Vibrations.
Which I didn't take vibrations. That's more you. For me, I took more antenna and, because it's electrical. So I took some other courses like that.
Electrical had the analog to vibrations, which was any kind of oscillating circuit.
Oh, okay.
Well,
we did that. Okay, so then we did that. But for me, I remember there was a class called. It was a without class. It was EE 381. It was called, or 380. It was called electromagnetism. Okay, and that's a class where most people flunked. But it was just mathematics. And by the time then I could do integration. I mean, I always could do integration, but my Cal 3 integration got better. So that class was supposed to be the hardest one for everybody. Was biggest joke for me. Nothing had happened.
That was Maxwell's.
Well, I was before Maxwell's. You see, Maxwell is of course after that. Maxwell equation is in your senior year we saw the Maxwell's equation. But I don't think, it's something about, it's electrical, so what it is, it's about loads on the sphere. You put electrical load and what was the total electricity that you had, so you do triple integral over spheres and stuff like that. You're right, you talk about flux. Yeah, so maybe we did Maxwell, maybe you're right. I
remember divergence theorem was heavy.
Maybe you're right, but he didn't do it for me. But I was scared of math because of Cal 3, which had scared the hell out of me. And then I was so scared I take linear algebra, just for fun. But I'm so scared I take linear algebra for non-math majors. So it's a baby linear algebra, okay? And of course, as soon as I take it, it's a class I already had in high school. I mean, I was trivial. I mean, anyways. So I'm like, let me give this math another shot. So then I take this course called Advanced Calculus 410, which is it's a proof course, epsilon and delta proofs. It's kind of very much related. Did you take analysis here in the?
Yes.
It's kind of related to our analysis graduate program. It's kind of,
Yeah. Yep.
So I take that class, and of course that's exactly what I'd done in high school at the French system. So that class, once I took it, I felt at home, and it was obvious by then that I should be a math guy. But by that time, I already had more than 120 credits of E. So instead of doing kind of a double degree, I did a double major. I did a double degree. I actually effectively got 2 degrees.
Wow.
So I've got a badge. I think they're both BS, I think, in math, and then in E.
See.
I then applied to grad school in College Park.
I remember coming out of high school, I kind of restricted myself to anything science related and math and computer science included.
Oh.
Because those were my strengths. So I went into mechanical engineering, but then there were so many parts of engineering, like the business aspect.
That's true.
The marketing research.
And that you didn't care, but
No, and then I worked for UPS as a plant engineer.
Oh.
Full time, 6 months, and I quit after 6 months because
You didn't like it.
I didn't like it, and it took me a while to realize that what I liked was math and physics. Theoretical.
Well, it's kind of
physics.
funny because it's a bit your story is a bit my story. I never actually got to a job, but it's clear that math was my and the kind of math I do is really harmonic analysis, which is completely pure mathematics. I mean, I'm not I don't know if I apply my stuff. It's just just kind of think about math. And
I remember liking the sciences like chemistry, biology, physics, but
well, see, you're lucky because I could do physics, but biology, I mean chemistry.
there were so many aspects of those fields, like laboratory work and just
Never liked
kind of
that.
hands-on.
So that you like?
labor.
You didn't like
No, I didn't.
Okay.
I thought it was like tedious, and I'm like, when am I going to get to the real?
that? So you're more of a theory kind of guy.
Yes.
Ah. Have you ever thought about doing in electrical engineering, the big theory is when you do signal processing. Have you ever thought about that?
Yeah, I read about it for fun a little bit, but I don't know much about it.
Because that's the very mathematical part of the, signal processing. That's interesting. Okay.
Do you remember something called control systems from electrical engineering?
You see, now I'm going to tell you something. Let me tell you something. When I started in 77 or 77, we didn't have I know you guys don't know, but in computers what we had to do is we had a mainframe, and we used something called punch cards. I don't know if you ever heard of that. You go someplace, you have a card, you put the card in, and you tap one line of code, and it makes hole into the card. So then you come out with, let's say, 150 card, which is 150 lines, and you give it to somebody, so again, write it on the mainframe, and if you make one mistake, nothing runs, and you come in, like a day later, and it tells you it didn't run. And it couldn't even tell you what the mistake was. You had to go to every card to find out where you messed up. So that's where I started. And then I remember I graduated in 81, and I remember in 1979, Maryland had something which blew us away, College Park, called the Modem. Well, basically, there was a little computer. There was a phone thing with 2 big holes for the phone. You call the phone or whatever, and then you put the phone, the physical phone thing on this, and somehow the phone could talk to the computer. So now, instead of doing the cards, you could tap your lines on the computer, went to the phone or whatever, and then that went directly to the... So if there was a mistake, you kind of knew it pretty quickly, and you could fix it. And that was like a big... but of course that was before the advent of the little computers, what do you call them, the PCs, and that came in because I remember by the time I finished my PhD in 1990, in 88 and 89, I remember we had those friends of ours that were ahead of us, and in '86 or '87 they already had a PC. That was like a big, having a PC, a personal computer. That was a big thing. So for me, I was at an age where we still were doing what we call passive circuitry. I told you about what do you call this thing? The transistor.
Yeah.
But the passive circuitry is made with resistance, inductor, and capacitor. Okay? The capacitor is basically a derivative operator, the inductor is an integral operator, and resistance is just free stuff. And basically, you had no, whatever power you put in, what came out was less. In a sense, you couldn't boost the power. What the resistor could do with some return loops is you could jack up, you could amplify. I mean, that's what an op amp is. You put whatever power is, and what comes out is way bigger than what you put in. I mean, that's why it's called amplification. That's what an amplifier does. It kind of, that was a big invention that came in '57, really.
That's well, I learned those things in control system. Control system was, remember feedback?
Exactly. That's exactly Boolean algebra and then the feedback. Yeah, exactly. So that I did.
So we would assemble those diagrams, op amps.
That's it.
The derivative integrator amp.
So that's why you had to use. See, that's a classic reason why people had to use AC, alternating current.
Yes.
Because if you put a direct current and you put a derivative, it's zero.
Flat.
It's flat. So you need to kind of.
Do you remember Nyquist?
Absolutely, Nyquist block. Oh, I did that. See, that was electrical engineering. That's a log thing here, or Nyquist plot. Yeah. Oh, you did that too?
Yeah.
How come?
In control systems, we would do mechanical systems and try to control them with electronic.
Okay. So you need a fair amount of electronics then.
I guess so. Yeah, more than I was expecting.
Yeah.
So we went from robots with mechanical arms and motors to Nyquist ability, talking about holes and poles.
Yeah, absolutely.
And then, I don't know if
you that's a mathematical thing. The holes and poles comes when you do Laplace transform, all this good stuff. Yeah. Complex analysis, absolutely. Residual theory. Yeah.
If I remember correctly, holes and poles there was a relation to the fundamental theorem of algebra.
Absolutely, because it comes from the complex thing. Yeah. The fundamental algebra simply says that